Thank you guys for coming out. And today, what I want to do is talk about some research that we did with the U.S. Department of Homeland Security, or funded by the U.S. DHS Science and Technology Directorate Cybersecurity Division, and look at how that's kind of evolved, and something that I've been looking into a lot lately, which is the application attack surface. How do you look at and calculate, measure and track application attack surface, and how can you use that? And so we're going to look at some tools that we've developed and released. Again, you can pull all the code off the GitHub site for all the stuff we're going to talk about here today. And what we're looking at is how you can use access to source to improve the quality of web application penetration testing, or as we'll talk about more properly, web application assessments, and the types of things that you can do to both improve the quality of the testing that you can do, but also increase the speed at which you can accomplish certain tasks. And again, as agenda, just provide a little bit of background, talk about why we use source code, look at this hybrid analysis mapping technology that we've developed and are continuing to develop. Again, we've got a couple of things that you can download and use, or pull the source down, build, and use. I want to talk about attack surface enumeration, identifying backdoors or potential backdoors in application, and quickly checking configuration settings. And we'll have time for questions at the end, but if you have questions along the way, again, this is a good-sized group, mostly because there's more than 4 of you, but also because there's not like 500 of you. So if you have questions along the way, please just ask, and there's the microphone is around there to ask questions, so that it'll go into the audio and stuff that they're recording. So that's a picture of me. In case you didn't know who was speaking. For some reason, the marketing people made me put that in there. I'm the founder, one of the founders of, and I'm the CTO of Denim Group. And I'm a software developer by background. I started doing a lot of early server-side Java stuff in the mid to late 90s. Did some early ASP.NET stuff in the early 2000s. But really what I've spent the majority of the last probably 12 to 15 years of my career doing is looking at how the software that developers build and that organizations field, how that impacts the security posture of those organizations. And so I'm a coder that's come into the world of security, as opposed to someone with more of a pen test or IT audit background that's now looking at web and mobile applications. So I have a developer perspective, whether that's good, whether that's bad. That is what it is. I help run the OWASP San Antonio chapter, and I also help with some of the OWASP SAM efforts, specifically around some benchmarking data that we're working to collect. We're going to be using some examples with OWASP ZAP. Who here is familiar with OWASP ZAP? Fantastic. Great tool, and what we've built is a plugin for OWASP ZAP. We've also got plugins for Burp and for AppScan. But for our purposes today, being an OWASP meeting, we'll look at how this OWASP ZAP plugin uses, or how that works, and how you can use that to accomplish some of the things that we're talking about today. So many thanks to Simon and all the folks on the OWASP ZAP team for providing a great platform that we can build these types of plugins for, build on top of. And if you want example code bases that you can use to test out some of this stuff, you can look at the Budget Store. That's an intentionally flawed Java application that the ZAP people use for a lot of testing. You can also look at the Java Spring Pet Store, as well as RailsGoat. Again, if you just want if you don't have example code lying around that you want to try this on, those are a couple projects that you can use to illustrate and test out some of the stuff we're going to be talking about. We're going to be talking, this technology is rolled up into the community edition of ThreadFix, available on GitHub. So you can, again, download the code off of GitHub and build this. And then I've also got, just for the sake of ease of whatever, I've got copies of a command line client that we're going to be looking at, and the ThreadFix plugin that we're going to be looking at, built and out and available publicly on Dropbox. Yeah, and these slides and everything are going to be posted as well, so all this stuff should be super findable. If it's not findable, you should just email me, because I'm easily findable. I'm just dan@denimgroup.com. If you've got questions, or if you're having trouble tracking any of this stuff down, just let me know, and I can work to make sure that you get access to it. Any questions so far? All right, good, smart group. So why use source code? And this is something that we have when talking with a lot of, or certain organizations. When we're talking about doing application assessments, especially in cases where we're doing like mobile application assessments, where our assertion is like, hey, if you're going to have us do this, you should provide us with the source code. And sometimes we get the question back like, hey, aren't you guys smart enough, right? Like the attackers only get the binaries. Why do you want access to the source code? And so really it comes down to a question of goals. In certain cases, and we've certainly done engagements or tests like this, where you want to prove a point to show here's what an uninformed attacker, if you have an uninformed attacker, someone that doesn't have any special access, this is what they're going to be able to do. This is the type of stuff that they're going to be able to find. This is the level of security insight that they'll be able to get into an application. And that's certainly valid in certain cases. But we don't see as much of that anymore, where it's, hey, here's an IP address, good luck, right? Here's your starting point, show us what you can find. In most cases, if you're an organization looking to test an application, whether that's an outsourced test that you're having done or whether that's budgeting the time for your internal researchers, your internal red teams, your internal testing teams, like really what you're typically looking for is how do I get the maximum amount of security insight into this application given the available budget of time. Does anybody here have too much time at work and not enough work to do? Right? Does anybody here's security department overstaffed? Right? You've got people just hanging out saying, I wish I had additional stuff to do, right? I mean, that's just the nature of the work in the information security industry in general. Again, 100% employment, and we need, whatever the statistics are, 1 million, billion more people working on the problem, and that's certainly the case in the application security world. Where if you're in a leading organization that's doing really well, you're going to have a 1 to 100 ratio between app security people and app development people, right? Like in your best case scenario, you're outnumbered 100 to 1. In a more realistic scenario, you're probably outnumbered worse than that. And so, in a situation like that, do you want to have your testers spending their time jailbreaking iOS devices, starting things up in the debugger, setting breakpoints, dumping decrypted memory, rearranging headers and things like that? Do you want them stepping through the binaries, reverse engineering? Is that really how you want to be allocating your scarce resource of your assessment time, right? Like our guys love to do that stuff, right? And they will sit there all day and all night, just chewing through and looking through binaries and whatnot, decompiling Java, reversing iOS binaries. They love to do that, but is that the best use of your time? If you can assume that attackers or a determined attacker is going to have more time available, probably than you're going to be able to buy in internal testing services or external testing services, do you really want to spend that scarce resource of budget going through all those hoops, or is it easier and more efficient just to provide the source access, assuming that an attacker is going to be able to get access to, in the case of Android, something that looks very much like source with crappy variable names, or even the course of iOS, a roughly source equivalent thing that's just less convenient and takes more time to go through. And so, if your goal is to prove a specific point, or if your goal is to test a specific obfuscation technology, then it may make sense to start, uninformed, or start and say, part of this exercise is to take this binary and turn it back into something that's going to be easier for a human to analyze. But if your goal is, I want to get the maximum level of security insight into this application, given a very limited budget of time, in cases like that, it makes sense to take advantage of anything you've got access to, which in most cases, in most situations is going to include some level of source code. So again, like our testers love reversing mobile binaries, but that is not necessarily what they get paid to do. They can do that in the work time when that's appropriate, but for the rest of the work time, typically their job is like provide the greatest insight into the security state of this application, given the constraints of the engagement that we're working with. So, any questions, any thoughts about that? Perfect. So, the technology that underlies all the stuff I'm going to talk about today is called hybrid analysis mapping, or we call it hybrid analysis mapping. And it was something that we originally built, or the original goal of this technology was to allow us to take static analysis results, for example, from a fortifier, a check marks scan in an application, and to correlate that to the results of dynamic testing from like an app scan or a web inspect or a burp suite. And this technology, the development of this technology, we started out, but it has been predominantly funded over the past 3 years by the U.S. Department of Homeland Security Science and Technology Directorate under a program called SBIR, or Small Business Innovation and Research. And I'll talk a little bit about that just because I think it's an interesting program and it's something that has been instrumental in us advancing this technology, and it's something that I think other folks that are working in the security space, again, the Science and Technology Directorate has additional interest in this area, and so this is something where I think there's opportunities for other folks to take advantage of this stuff as well. We're currently in an extension of a phase 2 of our DHS S&T SBIR, which is Department of Homeland Security, Directorate of Science and Technology, Cybersecurity Division, so there's another acronym in there, or Small Business, SBIR, Small Business Innovation Research. And what the program is geared for is to encourage the development of technologies that are of value to different federal government customers. And so there are things, the federal government, different departments will look at, here are technologies that we feel like we need in order to accomplish our mission. Are there businesses that we can fund that we feel are in a situation to prove out that certain technologies are viable and can be developed and then commercialized in the federal government as well as in the private sector? So this, again, we call this hybrid analysis mapping. The technology has been included with ThreadFix. And it's also, primarily today, we're going to be talking about some things that we found that you can do in addition with this technology that we hadn't anticipated when we originally built it. And so that's been also a very cool thing in working through this program, is we accomplished the goals that we set out to accomplish, but we also found additional uses for the technology, which, again, as a person who was acted as the principal investigator on this, it was that was a cool outcome to see. With what we built, we can do what we set out to do. We can also do other things as well. So again, the initial goal for this technology was to correlate and merge results between static and dynamic testing. And after we made that work, we found other stuff that we could do with the technology. And very specifically, our original goal was to determine the feasibility of correlating between HP Fortify, which I guess is now Microfocus HP Fortify, SCA, whatever that ends up being called, and IBM AppScan Standard. And that's just because we saw out in the marketplace a lot of organizations that had deployed those technologies, prior, AppScan prior to the acquisition, Fortify prior to the acquisition, and were in a situation where they wanted to be able to correlate these results, but just because of M&A activity and the way the industry had evolved, their vendors didn't necessarily have a vested interest in making that work for them. And so that was kind of the situation that we saw in a number of organizations. And as we'll talk about, again, the implementation that we have is agnostic of the static engine or the dynamic engine that you use. I'm just kind of mentioning this for the completeness of history. So is everybody here familiar with dynamic application security testing? All right. You look at a web application, you spider to enumerate the application's attack surface, and that really causes you to crawl the site like Google would. Let's start at the first page, analyze the HTML and the JavaScript, find out links to other pages, find out forms that we can submit, go to those pages, crawl from there, and figure out what are all the URLs this application will respond to, what are all the parameters that can potentially change the behavior. And when you're doing dynamic testing of web applications, you have the added challenge that Google doesn't have, or at least the challenge that you probably hope Google doesn't solve. But the challenge of you need to do some state detection, and you need to be able to train the scanner to be able to get past the login screen. So because you want to be able to spider the entire application, learn the entire application's attack surface, both for unauthenticated users as well as authenticated users. Once you've identified and established that attack surface, you essentially go through directed fuzzing. Let's send in a SQL control character, see if we get a JDBC error message back. If we do, that pattern could indicate the existence of a SQL injection vulnerability, right? Same thing, I'm going to send in some HTML control characters, I'm going to see if those come back unescaped. If it does, that could be an indication of a cross-site scripting vulnerability. And what a unique finding looks like to us in a situation like that is a combination of the vulnerability type. We use the MITRE CWE, the relative URL within the application, and the entry point into the application. And so you might have a relative URL of login.jsp, and for certain vulnerability types, for example, a reflected cross-site scripting, a SQL injection, you're going to have an injection point into the application. So you've got the relative URL of login.jsp and the entry point of the post parameter of username. So that's what we consider a unique vulnerability to be, just in the way that we've done our analysis. Similarly, static application security testing. You take the source code or a binary and you create a model of that application, kind of like a compiler does when it learns to do, when it works to create object or object code out of source code, or a VM is going to do. You want to build some sort of a model of the application, but instead of doing a transform, you instead perform analysis in order to identify vulnerabilities and weaknesses in the application. So you're going to do things like semantic analysis, looking for calls to known bad functions, or you'll do data flow analysis to look for tainted data coming into the application, traversing through the application, and being fed into a sensitive sync function, or control flow, looking for situations where you step through parts of the application in a way that may be ambiguous or maybe indicative that you hadn't properly considered things like return codes and stuff like that. And for us, what a unique finding looks like for us there is, again, the vulnerability type, and then that code or data flow path through the application that the data or the control takes in order for an attacker to potentially exploit that vulnerability. And so here what we see is an example where the get parameter called down there, that is the contents of that get parameter, the results of that get parameter call are going to be under the control of an attacker, right? Anything in a HTTP request you have to assume is under the control of a bad guy. That string that gets pulled out of there is assigned to the string username. So that string is then considered tainted. That tainted string of the username parameter then gets appended to some static text and assigned to the SQL variable. And then we see that SQL variable, which is also considered to be tainted now, passed into the sensitive sync function or of execute. So this is kind of a textbook example of a SQL injection vulnerability. So we're identifying the same type of vulnerability in this case, but we're doing it in very different ways. In one case, we're exercising a running application and looking for patterns in our request and response in order to identify the indication that there may be a certain vulnerability type present. In the case of the static testing, we're doing data flow analysis, watching tainted data flow from a source function to a sensitive sync function, and by knowing what that sync function was, we can then say, well, that statement.execute is a SQL, talks to a SQL database, therefore this looks like that same type of vulnerability that we identified before. So two different types of analysis, both that have overlaps in their capabilities, but also analysis that can find different things. So there's strengths and weaknesses to both. And so, what we're looking to do with this research that we did is how can we, if we're doing both of these types of analysis, how can I correlate that together to get a better and more complete set of results about potential weaknesses in the application, but also to deal with the volume of data that's going to come out. I mean, again, doing one type of analysis, if you're looking at false positives and things like that, that's one type of analysis is going to generate possibly too much data in the first place. So if you're doing two types of analysis, that's even more data. So what we're looking at, or the challenge there is, how can we efficiently correlate these so that we get a better data set that then we can use to start to do triage? Now, any questions about any of that so far? Fantastic. Okay, so our sub-goals here, we want to standardize the vulnerability types. And we, again, settled on the MITRE CWE, or Common Weakness Enumeration. I've said before and talked to the folks that run the CWE that it's like the democracy of vulnerability taxonomies. It's the worst one available, except for all the other ones that have ever been made. So I actually, have come to grudgingly like CWE. It's a little sprawling in places, but it gets the job done. And that's, it also has a lot of advantages for what we're doing, because a lot of the different tools will standardize that, they'll have their own unique mappings, but provide CWE mappings as well. So that makes it easy for us to support new technologies. Here's a new dynamic technology or a new static technology. You've got to build an adapter. If the vendor has already done the work to do the mapping to the CWE, that makes our job easier to support new integrations. We also need to match the dynamic and static locations. All right, and so we need to know when we pass a request into an application, we're sending that request into a particular URL, we need to know what code in the source code ultimately, but where does that code in the source code get essentially glued out to the web where that request can hit it. So we need to be able to translate between the URLs that an attack is being passed to and the source code that is going to be executed as a result of that piece of the attack surface being exercised. And in certain situations, kind of most basic PHP, JSP, it's easy in a lot of cases to figure that out, because your file structure in the directory maps pretty directly to the URL structure that the web application is going to expose. But if you look at frameworks like Ruby on Rails, if you look at frameworks like Java Spring, Java Struts, there's a separation between how your source code is organized and how that source code is ultimately glued out to the application attack surface. Similarly, we need to be able to figure out and determine for the parameters that are being passed in, also where do those end up touching the source code, or where do those enter the source code? And we'll talk about why it's important for us to be able to do those things. But those are basically our sub-goals. We need to be able to understand when these two different technologies talk about the type of vulnerabilities, we need to be able to correlate those. We need to be able to know where source code gets attached to the attack surface of applications, and we need to be able to understand when parameters being passed, or what for parameters that are being passed in, where that tainted data enters the application. So what we feed our engine is, first the source code. We can do analysis with partial source code, and you'll see that packaged with different static analysis results formats. Sometimes they'll have 10 rows above, 10 rows below. We did some work and we could get some results just taking partial source code that we ingested just from the files. But really, to get a good attack surface model, it's pretty important in most cases to have a full access to the full source code for the application. And again, you can pull that from Git, from Subversion, from a local copy. Then we look at the source code and the configuration files associated with it, and we attempt to identify the language and the framework type that's in use. As we talked about before, a Java JSP application, kind of plain vanilla JSP, is going to have very different behaviors in the way that code gets associated with the attack surface versus something like Spring or Struts. A similar case with .NET, MVC, web forms, and so on and so forth. So we need to detect that framework through identifying configuration files, file extensions, things like that, and that then informs our analysis. And some of the static analysis engines provide some additional information about this, and so when that's available, for tool vendors where that stuff's available, we'll pull that if it's available, but it's not required. And we take all of that and we put it into a unified endpoint database. And so essentially what we're looking to figure out is, for an application written in this language for this framework, based on this source code and the configuration files, what are all the URLs that this application will respond to? And additionally, for each URL, what are all the parameters that can be passed in that can potentially change the behavior of the application? So we want to know everything, any URL that you can hit, any parameter that you can pass in, because that essentially determines the application's attack surface. That's not necessarily the vulnerability surface, right? Hopefully in an application there are URLs and parameters that aren't subject to exploitation because they sit in front of vulnerabilities. But what we want to know is all of the attack surface of the application. And for each piece of attack surface, we keep track of the entry point in the source code that is ultimately responsible for that piece of the attack surface. So that gives us a database that we can then query. So to accomplish our original goal, which was I need to merge and correlate these static and dynamic results, you can essentially say, hey, I have a dynamic result. I have a reflected cross-site scripting vulnerability at the relative URL login.jsp, and it's for the username parameter. Then I query the endpoint database, and it says, well, this is a Java Spring application. So that endpoint, or that endpoint maps to the entry point in the code of com.whatever.whatever.logincontroller.java at line 62. Then we can look through the static results and try to identify, do we have a reflected cross-site scripting vulnerability where that source function is in the source code at logincontroller.java at line 62. If we find that match, then we can correlate those findings and say, we think that we've found one vulnerability, but that we have two pieces of information about this vulnerability. And that shows us some pretty good stuff because it shows us, here's the request that should come in, here's the data or control flow through the application that is going to be exercised, and here's the response that's going to come out the other end. So what that gives us is something better than what you see if you just have one type of analysis or the other. You know, a challenge we see with developers when we look at static analysis results is it's really easy to say, well, hey, that's not the way it works in production, right? That's, you know, I see the flow, but that's not actually exploitable. That's not the way it works in production. And so you spend a lot of time with your 10,000 results that your static analysis engine has dumped out, going through each one, being like, no, I really think this is a problem, and here's why. And no, I really think this is a problem, and here's why. And that's a horrible misallocation of time, right? When you're just like, no, if you would just believe me that these are problems, we could fix more problems or we could fix the problem in less time than it would take to adjudicate it, right? And so if you also, though, look on the dynamic side, there can be challenges saying, okay, well, I think I see why that would be a problem, but I need to see the source code to understand what the behavior of the application would be. Okay, well, where's the source code? I don't know where the source code is. We've got to go and track around and find that. So it's a similar problem to say, all right, when this URL gets passed in, let's grep through the code and find where, you know, in a Spring case, like which controller, gets attached to this URL. All right, waste of time, again, not an efficient use of resources, but if you can show a developer, here's the request and the response. So hopefully you believe that this is exploitable, and here is the data and control flow path through the code this is going to take. That puts the developer in a situation where there are hopefully fewer arguments about if something's actually a problem, as well as less hassle in saying, here's what you need to do to actually go in and remediate these vulnerabilities. So that gives you a much better picture. And again, the hope is that that lets you take less time to remediate vulnerabilities, less time to argue about stuff, which means you're going to, on the net, fix more vulnerabilities and have more secure software at the end of the day. Right? Like what I find increasingly is that looking at decisions that you make in application security, I mean, they're economic decisions of how am I going to allocate my resources. And so what we're trying to do with this technology is say, here are ways that you can be much more efficient with your resources, decreasing more risk per unit of time spent working through, remediating, testing and remediating these applications. Any questions about any of that so far? Yes.
If I'm configuring IIS to be my web server, I can configure it stupidly so that it unintentionally sends a lot of different kinds of requests to the same application. Can the tool take on the additional scope of the configuration of the web server?
Right now, the C#, the .NET and .NET MVC stuff uses the configuration files for the .NET MVC, but doesn't take into account that you might be doing something wacky with the web server configuration. But again, if you remember back to when we talked about the dynamic results, what we're ultimately looking for is the relative URL within the application. So if you say, I'm taking this ASP.NET application and it's going to live in this subdirectory on this configuration, like that shouldn't be a problem. But if you've got some kind of weirdo rewrite rule that says, you're coming in with XYZ, but we're actually gonna execute it as if it were this URL internally, that's something where, if I had to handle a situation like that, what it would probably make sense to do would be basically to reverse that type of change, using some sort of a script running over the dynamic results to say, find all the URLs if they match this pattern, like unrewrite it back to something that made sense. And so, again, I need to know more about the specific situation, but like we don't right now. Like right now, we take into account the configuration files of like like the web.config for .NET stuff, the Spring configurations and things like that. And we take that into account, but we can't like pull an IIS config or pull an Apache conf or something. Yikes! That's a challenging issue, right? So yeah, great question. But again, something that we probably work around that outside of the system, and then try to feed it in results like that. Excellent. Other questions? Great. Okay, so that's great. We accomplished our goal. Yay! We can all go home now. And again, that was we felt good about that because we set out to do something and we demonstrated that it could be done. But some interesting questions started to come up as on the tail end, or as this was kind of really starting to take form. Some questions started coming up saying, well, what other stuff can we do with this technology that we've built, or with these data structures that we're putting together? And so what we figured out pretty quickly is that we can essentially treat that endpoint database and instead of doing a very specific query saying, I've got this particular piece of attack surface, what line of code is associated with that? Instead, we can essentially do like a select star on the database and just say, dump for me all of the endpoints in that database. And what that should provide me is an attack surface map of the application. Here's all the URLs you can hit. Here's all the parameters you can pass in to each URL. And that's going to let us do some interesting things. We can visualize what the application looks like. What I'm working on next is looking at how, like tracking through git commits to watch how the attack surface changes over time, and starting to calculate some metrics around that. But so again, one of the things we can do, and we'll talk more about specifically what we're doing with this right now, but we can get all of the application's attack surface. We can also run that transform the other way, which is even if I haven't done static analysis, if I only have a dynamic analysis engine, I don't have access to any kind of static analysis technology, I can still take that raw dynamic result and map it back to the entry point in the source code. And that's not as good as providing the developer the full like control flow or data flow trace, but that's better than saying, this is in the source code somewhere, good luck. Right, and so given those capabilities, what we figured out that we can do is we can take that attack surface data and pre-seed dynamic scanners to short circuit some of the spidering process. We can also map dynamic results back to a specific line of code in a developer IDE. We're not going to talk about that as much today, but that's one potential use of that technology. And we can also, earlier versions of SonarQube, I don't know if anybody's using SonarQube in their environment to do like backlog tracking, not security specific, but backlog tracking for technical debt and things like that. A lot of development teams use that. Earlier versions of SonarQube required you to provide a line number mapping, which again, if you have static analysis results, you can do. But with this, if you had dynamic analysis results, you could also map those dynamic results into specific lines of code in SonarQube. And so, again, kind of depending on your environment, we've seen a lot of value in, if you're working with dev teams, to be able to have their technical backlog also include the security backlog along with it. And so that allows us, I think newer versions of SonarQube allow you to do mappings that are not tied as specifically to source artifacts, but I haven't messed around with that in a while. But again, with the previous versions, you needed that mapping, and so that allows us to do that type of stuff. So we're going to talk mainly about the attack surface calculation and some things that we figured out that we could do with that. And again, the first thing that we look at is doing scanner seeding. So as we talked about before, the typical behavior of a scanner, of a dynamic scanner, is give me a starting point, maybe train me to log in. I'm going to crawl the application like Google would. I'm going to look at the HTML. I'm going to look at the JavaScript. Maybe I'm going to look at the smarter scanners are going to watch traffic in the background, trying to detect if you're hitting AJAX or JSON endpoints and all that. But it's going to be a discovery process, and there are cases where that discovery process can go wrong. So if you have applications, for example, that have landing pages that link back into the application, but where there's never any navigation that goes back out. You see that in a lot of sites where you have like event registration and things like that, where you have these landing pages where you want people to submit information, but you're never going, you don't necessarily crawl back out. You also have situations of hidden directories, right? Hopefully all pen testers know to check for like /admin/reports, maybe use something like Deerbuster or something like that to try and like brute force enumerate this stuff. But if you have hidden directories, hidden URLs that you're not going to find any sort of a crawl, again, this is a way to add this scope back into the testing that's going to be performed during that targeted fuzzing and the dynamic scanning. What it also potentially identifies is backdoor unused parameters, because you can look at, here's all the parameters that you can pass in to this particular URL. Do we know what all of those are doing? Each of those have a legitimate use. So we currently have plugins, as I mentioned before, for OWASP ZAP for Burp Suite, and we've got an AppScan standard plugin in progress. Today we're going to talk about OWASP ZAP because OWASP ZAP is awesome, and this is an OWASP meeting. So one just quick thing, kind of some final thoughts about the work that we did with the SBIR program. In my humble and totally unbiased opinion, which I suppose I should mention that the DHS, S&T, CSD obviously does not condone or endorse anything I'm saying here today. But again, in my opinion, I think this is a really cool use of this program because we had the basis of some of this technology. We were doing some of this work, but getting that research contract or the series of research contracts with the DHS folks provided the impetus for us to develop out this technology. And so the ham stuff was always interesting to us, but it really required material investment to get to the stage it was today. Again, we think the research produced a successful outcome. We found other things we could do with the technology, and we've released a lot of this open source with the goal being to increase adoption, increase community participation, and things like that. And releasing it open source isn't a requirement of the program, but it's something that we wanted to do for a variety of reasons, both publicity reasons as well as I feel like that makes us a good steward of taxpayer dollars and whatnot. So again, the DHS funds this program. They don't necessarily endorse anything I'm saying, but if anybody's interested in the SBIR program, feel free to reach out to me. We kind of got mentored into the program by some folks that had done a lot of work in this space, and I'm happy to pass on whatever lessons that we've got. I think, again, I think it's something that proved to be a really interesting opportunity for us to advance some technology. So you can, to get the plugin that we're going to be looking at for OWASP ZAP, again, you can build the stuff off of GitHub. And there's instructions for that, and also if you have a running ThreadFix implementation, if you go to the little gear menu on the right, you can go to download tools, and there's a screen where you can download all these plugins. They get embedded in the binary or in the downloaded application, which is kind of makes it a little bit big, but it makes it nice because you've got the plugins of the right version and things like that. Again, you install this just like any other ZAP plugin. We've got a page up there for that, and like I said, we've got plugins also available for Burp Suite and AppScan. So first we want to look at, and because every talk needs a clever name, I found an acronym, ABC, and managed to stuff what we were going to talk about into those boxes. So that's why this is named as they are here. But we're going to look at attack surface enumeration. We're going to look at backdoor identification, and we're going to look at configuration setting checking. So for attack surface enumeration, again, we want to identify all of the URLs in the application's attack surface. And we want to identify all the parameters that the application is going to ingest that are potentially going to change the application behavior. And as we advance this technology, we're going to improve the quality. Like right now, we're just pulling in get and post parameters. In the future, we're going to be extending this to also support cookies, other HTTP headers, because those also, again, are in the request going into the application and comprise maybe a slightly less popular but also important part of the application's attack surface that you need to be able to track, to track and assess the security of. So why is attack surface a problem? Again, you find what you find in a lot of cases are there are parts of the application that the crawler doesn't get to. And that's become even more the case as people are moving to more like single-page applications, clever framework that people put together and things like that. You've got hidden landing pages. In a lot of cases, you'll have multi-step processes that, like a checkout process or something, where if the scanner can't figure out the right state in which to get there, or if it can't figure out the right values to pass in that lets it get from step to step, then your spidering process is going to leave parts of the application out there that you don't know about. Again, there can be unknown parameters that are only used in certain cases that might not be exercised or that might not be evident in the way that you crawl the application, and we'll talk more about this in a minute, but there may be also debug or backdoor parameters. Again, parameters that you're never going to see as part of a standard crawl on the dynamic side, but that will change and impact the behavior of the application on the flip side. This is also really good for things like if you have Spring applications that are exposing REST APIs that are supporting single-page web apps or mobile applications. Again, there's not a great way to crawl REST APIs, but this lets you enumerate those APIs, in a structured format, so then you can figure out what you, so that you can know at least what you, what you need to be testing, for those APIs. Benefits really is that it allows you to reduce false negatives from scanners. If you think of doing testing, you have situations where there are false positives, where a scanner says, hey, there's a problem, but there's actually not, where truly this actually isn't the way something works in production, or this is not actually exploitable. That has happened once or twice, I think. But this is looking at removing false negatives, which is the flip side of that, which is I ran some sort of a security test of this application, and I didn't find all the vulnerabilities that were there. And using automation, you're always going to have false negatives, right? There are things that scanners can't find, business logic flaws, authorization, authentication errors, things of that nature, right? You shouldn't expect scanners to find that, but it is reasonable to expect scanners to find SQL injection, cross-site scripting, those types of things that have a strong signature. But if your scanner, your testing is not able to get full coverage of the application, it's not going to exercise all of the application, you're going to miss vulnerabilities of the types that you could find, but that you won't find because they're in parts of the application that you can't see. So this is really allowing you that better coverage. And also looking at helping out people that are doing manual pen testing, this gives you a good map of this is the entire application that we're looking at, so that you can make sure as you're going through your checklist, as you're kind of working down your punch list of things that you need to look at, this can give you better confidence that you're testing all of the application. So first we're going to look at a command line client that we put together that basically you point it at the application in question, it goes, detects the language and framework, builds that attack surface model, and then it just dumps it out to the standard output in just a line by line file. And I think we've got a version, I don't know if this is pushed out yet, but we also give you the ability to dump this out in JSON, which you can then do more like fun scripty stuff with in a little bit easier way. But basically you use java-jar, whatever the jar name is, which kind of updates a bit over time as the version increments, and then you just point it at the source of the application. And it's whatever the jar file, it's the jar with dependencies. And basically what this does is outputs a list of HTTP methods, the URLs associated with them, and the parameters based on the analysis that the ham engine did on the source code. So this is the application attack surface that we've been talking about. So if we run that on the budget source code, what we see is that we basically see, and again, this is a basic JSP application. It's going to accept posts and gets for both, for any of these requests. And this basically enumerates all of the pages in the application as well as all the parameters that you can pass in. And so this is a great way just to dump stuff out, and as a pen tester, this gives me some interesting information that I can look at to start asking questions about. And again, we'll show, in a minute I'll show the ZAP plugin where this is even more useful. But again, by doing this, now we know here's all the stuff that there should be in the application. all the parameters that we can pass in, and I can start to ask questions about the stuff that we've found in there. It's nice that we were able to look at the source code and dump that data out. And again, getting that in an even better structured format like a JSON or something like that, can let you do a lot of interesting things. We've looked at doing stuff like generating Selenium scripts based on that to make sure that we can crawl the entire application if we want to make sure we're exercising an application for like IAST or something like that. Again, there's a lot of interesting things that you can do if you get that attack surface in a structured format. And like I said, I think there's also some really interesting things that you can do if you look at like watching that attack surface change over time as you look at successive commits. But what's potentially even more valuable is to be able to embed that in your testing so that we can augment the work that the DAST scanners are doing based on this data. And so we've written a plugin that allows you to import application endpoints from source. And so here's the location of the source that we have on disks, or on the disk. No. And here is the location. There we go. Here's the location of the scan. And so what we did there is we basically ran the analysis and then stuffed it into ZAP. So now ZAP's starting point for any sort of spidering that it's going to be doing is going to, the starting point is going to be, from where we, from where we like calculated, right? And so, for example, we're going to know about potential attack surface that we would miss, like this admin.jsp page, or other pages that, again, that you wouldn't find in a crawl. Like if we did an unauthenticated crawl, what we find with Budget is it'll let you go to that admin.jsp page, but you're not going to see that admin.jsp page in any links, in any JavaScript or anything like that. So on more complex applications where you have different parts, again, multi-step processes, this is going to tell your scanning engine about everything that's out there, so you can make sure that you get, that you fully crawl the application and have access to all the different, all the different parts of the system, so that you can hopefully avoid, any false negatives associated with things that you meant to track but did not. There we go. And I think I'm going to not go into full screen mode because I think that made it mad last time. Okay, so any questions about the attack surface enumeration stuff? All right. Again, good for both manual pen testers to have an understanding of what all the stuff that they need to be looking at. Great for the dynamic scanners to help reduce false negatives. Again, having more knowledge about the application and what its behaviors should be is only going to help you as a security tester. And to be able to find that in a very quick way, I mean, just looking at that analysis, we're not doing full control flow, full data flow analysis of the application. So it's not like we're taking the amount of time that you would see in like a, like a full Fortify run or something like that. This is doing like very simple, like tokenized string-based parsing and things like that. So we're doing very quick analysis, even for really large applications. It runs like in real time, basically for 100,000, 200,000 lines of code, even up from that, it's just very quickly chewing through strings, not doing any kind of path prediction or any analysis like that. So another interesting question is, what are all of the parameters that an application will respond to, and are all of those parameters supposed to be there? And my favorite example of this is a Cold Fusion application I worked on a number of years ago, where if you sent any page in the application a parameter named D, the application would take the value of that D parameter and delete whatever that order ID was in the database. So if I want to delete order number 1000, I just say, append $D equals 1000. That order 1000 gets deleted, right? Was that a sinister backdoor? In this case, I don't think it was. I think it was a lazy developer who didn't want to go into the admin console and delete orders when he was doing testing, right? But as a tester, that's really interesting for me to look at that and say, what exactly does this parameter do, right? It's not like you've got a user registration form and it has first name, last name, address 1, address 2, city, state, zip. Like, oh, okay, well those, I can guess what those are all supposed to do, and from a business logic standpoint, I can't think of any really nasty things that we might want to do with that, other than your kind of standard fuzzing stuff, SQL injection, cross-site scripting, and maybe some put some negative values in or whatever. But if I see a parameter I don't know where that is, then that makes me curious, and that's the type of thing I want to make sure to include in my analysis. Similarly, if we look at the ZAP, which is, where did ZAP go? There it is. If we look at ZAP, what we see is that there are a number of pages taking this parameter called debug. What does the debug parameter do? I don't know, but as a pen tester, I'm pretty interested to find out. Right? And as a person who's going to be fuzzing that application via the automated analysis of ZAP, that's pretty interesting to me as well. So what this can help, this type of analysis can help identify for you is, here's stuff that you certainly want to include in your automated fuzzing, but here's also things that I don't understand what the behavior might be, and these merit further investigation and further, further inspection and discussion. And so to be able to do that, again, you're not going to find that if you're just looking from the outside in. You might find it if you like grep through or run through all the different, if you're looking through all the source code. But the type of analysis we're doing basically pulls that out and says, for this URL, these are the parameters that are going to be passed in. If you know what that page does, do you know what these parameters are supposed to do? If not, take a further look. And so, again, the idea here is if you've got limited time to be doing testing, if we can more efficiently create a better list of things to investigate, that's going to save me time in the testing, but also potentially allow me to, to find things that I would not have found otherwise because I didn't have time to get to them. And that's similar, if you've looked, there's a great presentation that Chris Wysopal did at the San Jose OWASP AppSec, and this has been a number of years ago, but it's still a fantastic presentation. He essentially looks on the other side, what are static analysis patterns that you can look for to potentially identify backdoors. Some really, really cool stuff that they did looking at examples in open source or commercial, commercial applications that have been released. But some really interesting stuff, like how do you identify potential malicious code? And that's typically something that's like a scanner is not going to be able to tell you that something's malicious, but a scanner can alert you that something is there, and then a human can look at that and determine, yes, this is actually malicious. Next up are configuration settings. A lot of MVC frameworks have auto-binding capabilities, which is great if you're a lazy developer. And what great developer isn't lazy, right? Laziness and hubris are those the two best characteristics for developers. So auto-binding is great because what that lets you do is it lets you create your your beans or whatever your objects are, name parameters, and they get wired directly to those objects, right? Super convenient, great when you're doing create, retrieve, update, delete type pages, things of that nature. The challenge is that that type of behavior can lead to problems, especially if you look in like a Java or in a Ruby on Rails setting where you have essentially trees of objects that are being set based on what's in the request. So if I can go in and set all the different properties of a particular bean in Java, some of those it may be completely valid to set. First name, last name, whatever else it might be. Others, it might not be acceptable to set, such as is admin, date created, other things like that, right? So there are times where this auto binding, which is very convenient, leads to problems. Similarly, in auto binding situations where you can step down the object tree, that increases the chance that you're going to be able to hit some sort of a method that you shouldn't be able to hit, and be able to find some sort of a security issue. So with this type of analysis, because the HAM engine understands the MVC frameworks, and in the case of like Spring and Ruby on Rails, it goes through, like with Spring, it goes through and parses all of the classes that are annotated as being model classes, identifies all the properties that'll exist in that bean, and also looks at the object trees that get created. And so it then knows here are the parameters that Spring would pass in to set deep into these object trees if that is not being prohibited by the configuration of that application in Spring. And so what that lets you do what that lets you do is dump out here all of the, again, we're looking at all the URLs and all of the parameters that can be passed in. And so we can look at situations where we have, oh, on this particular page, you can set the user and user.password. Do we want to be able to set user.password there? Maybe. It's an administrative page. But maybe I don't want to be able to set that. Do I want to be able to, for the benefits object, set this .backup and this and these .upload parameters? Right? Again, you're going to have to understand or learn about the application and how it is going to be treating these particular auto-binding situations. But this at least highlights situations where these auto-binding scenarios are possible, where you can go, which parameters you're going to be able to set, but also when you're going to be able to walk down the object tree and set parameters. And so when I was quickly looking through things, it's interesting to me, you're looking here, account settings, like, yeah, that's probably okay. Up here, event type, that's probably something that should be, that should be allowed, but maybe not. And so that can potentially highlight situations, again, that you as a manual pen tester want to look into further to say, what does it mean if I can control these fields in this object? But also, from a fuzzing standpoint, what happens if I pass in and fuzz these, fuzz these parameters that the application will be listening to because auto-binding is turned on and because the configuration of the auto-binding for this application allows allows requests to go in and set parts of the object tree this far down. Any questions about any of that? All right. We're close here. So we've covered a couple topics, looked at automation and tools support, right? So I think that it's very interesting, or it's very valuable to be able to look at ways to use source code when doing pen testing. And the most basic way to do this is to have the source code to go and review. If you have questions about, well, what is the application actually doing here? Is this a problem, right? Again, being able to look that up rather than spend a lot of time crafting queries and things of that nature. Just having access to source code has value from a how do I economize, how do I make myself more efficient in doing this testing. But I also think that in addition to there being value in doing full static analysis of applications, I think that even limited static analysis can provide value when you look at taking the scope of an application and quickly learning things about the application, because they can help to highlight things that pen testers might not notice. They can make it a lot more efficient for pen testers to identify things that they need to look into. And again, they can help pinpoint places in the code that you want to look to learn more about certain specific behaviors. So what are the other kind of things we can do? I think there's a lot. We've got that we've worked on. I don't know that it's finished yet, but we've introduced the concepts of authentication and authorization to the hybrid analysis model, or the attack surface model that we're building. And so in a situation like that, if you run static analysis against a giant application, you find 1,000 cross-site scripting vulnerabilities, you can take the knowledge of the authentication and authorization requirements, 4 pieces on the attack surface, cross that with the source code and say, I've got 1,000 cross-site scripting vulnerabilities. Here are the 100 that you can touch as an unauthenticated user. Here are the 900 where you have to have some sort of an authenticated role or some sort of authentication and maybe 1 or more roles in order to get to this stuff. All right, so if I'm looking at dealing with large volumes of data coming out of testing programs, we can start to slice and dice that stuff and say, I'm going to look at the unauthenticated SQL injections first, because those are super terrifying as opposed to the authenticated SQL injections that are just normal terrifying, right? And so by starting to understand more about how the application source code relates to the application behavior. I think that opens up situations where we can start to do a lot of really interesting type of analysis that can find more vulnerabilities, but also, and potentially more important in certain cases, it can make us a lot more efficient in dealing with the vulnerabilities that we've identified, in sifting through and prioritizing the vulnerability data that comes out of this testing. Because, again, a lot of these tools, especially static analysis engines, if you haven't tuned down the rule sets, they tend to produce a lot of results, which is great. You want to have that type of security insight, but then you're faced with this data management problem of how am I going to get through these results? What's the most efficient way for me to get through? I'd love to see, and I think we've got some projects that we're hopefully kicking off in this space, but a better framework, a more comprehensive framework around this, how you can use these types of tools, and how that fits into a more complete pen testing methodology. And again, I love the idea of automation, full automation wherever possible. But I think there's a tremendous amount of value in tool support or in augmenting pen testers with automation to help them build their list of things they need to do, to help prioritize those lists. Again, because more and more the case that that we see in looking at organizations trying to manage their testing programs, manage their application security programs as a whole, you're forced with making decisions about how do I, am I going to do A or am I going to do B because I can't do both? Right? And if everything is equally important, then nothing is actually important because you can't make decisions between different tasks. And so to the degree that we can make people more efficient and help them prioritize what are the activities that truly matter, I think that puts us that's the only approach that we're going to be able to take in order to deal with the scale problem that faces folks in application security right now. So that's what I got. Only one crash, which is good. So we're going to have step one, or phase one and phase two, which is good. Yes. Oh wait, and there's a.
I didn't understand what you meant by auto binding.
Okay. And so for certain frameworks, there are naming conventions for parameters that are passed in that allow you to set the value of fields and objects on the server side. And so you'll have a bean that says, I've got a user object, and it has a first name, a last name, a username, email, address, and things like that. And so you'll have conventions that say, if to this page I pass in user.address1, that's going to automatically set up when we start executing. That's going to automatically set up. I'm going to have access on the request on the server side to a user object that has a property of address1. I don't have to, as a coder, I don't have to go through and say user.address1 equals request.getParameter user.address1. Instead, those are automatically bound to those objects. And so the danger is if you've got a bean that has some list of fields, some of those it may be acceptable to auto bind. User first name, last name, address, things like that. Other things such as a user status or a role or things like that, you wouldn't want set. And similarly, you run into problems if you have these like deeper object trees that you're allowed to set. You can like reach deep in and potentially be setting stuff that you have no business changing from that from that location. So. It's again a thing that like in the Rails environments, in Spring environments, like it's those kind of MVC environments where you see that type of behavior supported by the framework. And so again, using the knowledge of the framework, we can dump that out and identify situations where like, hey, you probably shouldn't be able to like get 5 levels down here. That this one screen is probably not supposed to be setting all that stuff from this place. Yep.
How do you handle the problem of pages, single page applications, whatever, where internal state is maintained, and to get to a particular page, you have to transition through a bunch of events?
Right, and so if you do have an application that requires specific steps in a row, and where those API calls, in step 3 of the process, where that API call is going to actually check the state and not assume that the front end has walked them through. Yeah, in a situation like that, like we don't, we're going to hit that we're gonna tell you about it. Well, here's the third function you can call, or here's the third method you can call. And if you fuzz it and hit that method and it says error, you didn't hit method 2 before this, there's no way around that with the type of analysis that we're doing. But in situations where you have those 3-step processes and that third method is not checking, it's relying on the front end to have enforced that desired path that you want the user to go through, then you're gonna, then you'll know about that part of the attack surface and are going to be able to potentially exercise.
Okay, so you don't have any state path, so to speak.
Yeah, no, I mean, especially not between whatever, not for something like that with the level of analysis that we're doing, like multi-request.
That'll be your next grant, right?
Yeah, that's an even slightly harder problem to solve, I would suggest. Any other questions? Well, very good. I'll be around here for a while if folks want to come and catch me after the thing. I want to thank you all for coming here because I was very lonely when we only had Chris and 4 other people. Again, thanks for coming out tonight. Feel free to reach out. I'm easy to track down, just Dan at denimgroup.com or Daniel Cornell at Twitter. And you all have a great evening.